Industrial and commercial businesses pay for electricity by the kilowatt and also pay a demand charge expressed as kVA, kilovolt amps. In an alternating current or AC electrical supply, power factor also comes into play. Power factor is the ratio between the actual power being used and the apparent power being drawn. Let's first look at some basic terms. kW is the power that actually powers the equipment and performs useful work. We'll call it active power. kVAR is reactive power. It is the power that magnetic equipment such as transformers, motors and relays need to produce the magnetizing flux. This is non-useful power. kVA is apparent power, the total power consumed, kVAR plus kW. Here is a simple analogy from everyday life to help you understand power factor. It is a hot day. Here is a glass of beer. The thirst-quenching portion of the beer is represented by kW. The beer comes with some foam. I'm sure you'll agree the foam doesn't quench your thirst. The foam is represented by kVAR. The total contents of the glass, the beer and the foam is represented by kVA, and you pay for both. A power factor of 1 would mean 100% of the supply is being used efficiently. Therefore, there is no reactive power. kVAR would be very small. The foam would be approaching 0. Unfortunately, a power factor of 1 is not obtainable because equipment such as electric motors, welding sets, and fluorescent lighting create an inductive load, which will cause the power factor to become less than 1. A large electric motor might typically have a power factor of about 0.85 at full load. Let's say our motor is rated at 100 kilowatts and the power factor is 0.85. The electricity supply would have to supply 100 kilowatts divided by 0.85, which equals 118 kilovolt amps, kVA, to provide the 100 kilowatts to run the motor. They would be supplying 18% more electricity than they are charging for. And that is why power supply measures maximum demand kVA, because the current drawn is dependent on the power factor for the same load, and the current drawn is calculated with kVA. Bad power factor means that money is unnecessarily spent, and there is an increased load on the electrical distribution network. Both can be reduced through the use of a correctly installed power factor system. What causes bad power factor? Bad power factor can come from the following sources: transformers, induction motors, high-intensity discharge lighting, welding machines, arc and induction furnaces, and power rectifiers. Immediate and significant savings on your electricity bill. Improved plant efficiency and longer equipment life. Increased capacity of electrical infrastructure and equipment, reducing loads on cables, transformers and switchgear. Elimination of low power factor penalties. Contribution towards reduction in carbon footprint.